Okay, so we finished all of our stuff on how to deal with fractions. Now we've got to look at what fractions play in our mathematical world. It is a fact that fractions, decimals, and percentages are all related. But we do have key times when we use different ones, all right? It is important that when you are learning to do a particular skill, you find out whether it should be written as a fraction. So in probability, we like fractions, all right? Sometimes when we're looking at percentages, people want to write percentages for probability. That's really not a go. It doesn't explain it the way we like it to be explained. But we do need to be able to swap between these things. So they all have the same value. We just need to be able to say, well, how do we get from one to the other? So if we are looking at changing a fraction to a decimal, we are recognising the fact that the fraction line is now a divided by, all right? So when we work with it, we're going to say that this is equal to 1 divided by 5. Now, we haven't done a lot of division of decimals, but my assumption is that a lot of you know how to do it. Just going to recap it really quickly. If you're dividing 5 into 1, you're saying how many times does 5 go into 1? It doesn't. So, now we look at this as though it's a 10. We say how many 5s go into 10, and we've got a 2. So you can see I put a point in both places and added a 0. I continue to add a 0 until I can't, or I've got so many decimal places, this is time to stop, rather than spend my whole life dividing. All right, so there are some numbers like 7, which when we divide by 7, we want to stop after 3 or 4. Okay, so the answer to this is 0.2. Now, there's a tendency to want to write it as 1.5. All right, seen that done very, very many times. 1.5 has absolutely nothing to do with this. This is 1/5 of a whole. So cutting it into 5, if we cut a whole into 5 as decimals, there's 0.2, 0.2, 0.2, 0.2, and 0.2. That makes 1. All right, so thinking carefully about it when you're answering it, not just looking at the numbers and say it must have something to do with 1 and 5. It doesn't have anything to do with 1 and 5 apart from this part here. All right? So there are lots of things that we could have to do in division, like this one, which is one of those ones that I talked about. So 7s into 3 don't go. So 0 point. Okay? That part's easy. 7s into 30 go 4 times with 2 remainder. So go down the page. 7s into 20 go twice with, so 7, 2s are 14, leave 6 left over. 7s into 60 go 8 times, which is 56, right? So we take 56, that means there is 6 or 4 left over. Now, we can keep going with this one, and in fact, we can spend our whole life dividing 7s into 3 because it continues. There is a pattern. It does at some point start to repeat itself. We're not going to deal with that today. We're going to just be happy with 3 decimal places. All right? So if we were going the other way round, how would we do it? If we were going from decimals to fractions, what do we do here? We can just know. It is okay to know the straightforward ordinary ones, but if we didn't know, what would we do? We need to make this into a fraction. Anybody know? Okay, so the rule is that we take the number, the 4, and we put it over a 1 with however many decimal places there are. There's 1 decimal place, so we have 1 0. That means when we simplify this, we get 2 over 5, dividing the top and the bottom by 2. All right? So if we had this one, we'd take the number 65, we'd put it over a 1 with 1, 2 zeros. And we'd simplify. 5s into 65, go 13. And 5s into 100, go 20. So 13 is a prime. We know we can stop there. 13 over 20. If we couldn't, we keep going until we simplify. All right. So if we have to go between decimals and percentages, one like and one like 2 up. We haven't really touched on what percentages is, but we all know what a percentage is, what it looks like, and the relationship between a percentage and a decimal is that we just multiply by. Percentages are out of 100, we multiply by 100. 0.2 times 100. When we multiply by 100, what happens? We move the decimal place along 2. So we go 1, 2. There isn't anything there. We need to fill it in with a 0. So 2 and a 0. All right? Or a hard one. Not really harder, because it's just that times 100. Move the decimal point 1, 2. It's 47%. All right? So, if we're going from percentages to decimals, what do you think we do? Yeah, well done. Can talk louder than that though. But you're quite correct. We divide by 100. So if we've got 27%, it's going to be 27 divided by 100. That means move the decimal point, which is currently sitting here, backwards this way. So it's going to be 0.27. Or if it was 8%, 8 divided by 100, moving the decimal point twice, 1, 2, we have to add a 0, 0.08. That one's a common one to get wrong because people want to write 80%. 80, sorry, 0.8 instead. 0.8 is 80%. Last one, fractions, 2 percentages. We just do it twice. So, oh, that's the wrong place for that. That's the E-G. We're going to do this, and then we're going to do this. All right? So it goes from a quarter equals 0.25 equals 25%. That one was easy, and we should know those ones. But what if we don't know it? Like 3 eighths. So 8 into 3 is 0.375 when we divide. Now we have to times. So we're going to move it twice. 37.5%. Right, jumping twice. And if we're going from percentages to fractions, Then again, we just do them twice. So we're going to do this one, then we're going to do this one. e.g., 28% equals, jump to here first, 0.28, which equals 28 over 100, 2 zeros, and now simplify. 14 over 50, 7 over 25. All right? If we have whole numbers, then they just stick around. So if we had a whole number here, 1 and a fifth, it'd be 1.2. If we had 4.4, it would be 4 and 2/5. If we had 4.2, we're going to get an extra number at the beginning, 420%, etc. So that 4 would just hang around.